so you guys can just pick up from where we left off on our last notes. Okay, I mean, you don't have to start anything new. Just right after the last example, just record this. So that word is synthetic. Synthetic division. Think of it as being fake. Synthetic. All right, this is like fake division, but you'll love it. All right, you can only apply synthetic division, the shortcut, if the divisor is of the form x minus k. And all that means is it has to be linear. X minus 2, x minus 7, x minus 5, x plus 3. Plus is okay because you can rewrite that as x minus a negative 3. What you can't use this synthetic division for is if you're dividing by, say, 2x minus k, if the coefficient here is anything other than 1. Or if you have x squared minus k. All right, so the shortcut can only be applied if you're dividing by a linear factor with a leading coefficient of 1. If you don't remember the synthetic division shortcut, you can always do polynomial long division, but it might be in your best interest to see if you can memorize the shortcut. All right, let's take this cube and divide it by x plus 2. All right, just kind of be patient through the first 2 examples. By the time we get to the third one, you're going to be pros. All right, so if we're dividing by x plus 2, that factor, then we're going to look at the 0 of this factor, meaning we're going to be looking at negative 2. The 0 meaning if you set this equal to 0, solve it for x, you're going to get negative 2. All right, so let's look at the 0, negative 2. And notice what I'm going to do. I'm kind of building an array of numbers, an array, A-R-R-A, array of numbers. And I'm going to kind of like put this in its own little box up here, negative 2. Then what I'm going to do is across the same row as this boxed negative 2, 0 of that factor, take all the coefficients, starting with the highest degree, so 5. And if there's a missing term, you'd want to fill in a 0, like we did in long division. So we've got 5, we've got 8. The coefficient here is negative 1, and then we have a constant term. They're supposed to be lined up in a row. Then leave a blank row, and then put in a line all underneath it. All right, we're going to do synthetic division. Okay, so we're just going to work with the coefficients. We're just going to work with numbers. We're taking the whole variable piece out of this. All right, so the first step is always bring down the 5 underneath the line. Then you take and multiply this underneath the line by the 0, negative 2, you get negative 10. Well, you place it in the next available position right here, and then you add down again. So 8 and negative 10 make negative 2. All right, start the whole process over. Multiply by negative 2, get positive 4. Collect down, get 3. Multiply by negative 2, get negative 6. Your sum is 0. All right, you're not always going to get 0. It's just so happens that what we say is when you get 0 at the end of the problem, if you had done polynomial long division, your remainder would be 0. This is your remainder right here, your remainder. And in this case, our remainder is 0. So what we can state further is x plus 2 factors evenly or divides evenly into this third degree equation. So like polynomial long division, nothing was said about factoring it completely. So I don't think I'm going to do that, but what I am going to do is I'm going to come over here and show you another way to express what you just found. Let's set up a fraction that explains what we just did. We use the shortcut method of synthetic division to divide this third degree polynomial by this linear factor. and the result of doing that division, okay, is this. These coefficients right here are the coefficients of the second degree factor, I guess we'd call it, since the remainder is 0. If we start out with this row being the coefficients of the third degree, then these are the coefficients of the second degree factor or quotient. So I'm going to come over here and say, okay, well, I guess when I divide, I'm going to get 5x squared minus 2x plus 3. Times the divisor. Oh, no, hang on, back up. Let me back up. When I divide, I get this quotient, and that's all. I'm not rewriting it in a different form. If I was, I wouldn't need this division here. Sorry about that. This is late, and I don't have time to edit it, so I'll just say that. Let me see if I can erase this right here. There we go. All right, so this division problem can be set up as a fraction, and when you divide, you're going to get this quadratic factor. If I wanted to check my work, what I would do then is I would multiply this answer by this divisor, and that should produce that third degree equation. Okay. All right, let's do another example using synthetic division. All right, we're going to take a third degree equation and divide it by another linear factor. And again, look at the factor you're dividing by. I say factor, but the expression you're dividing by. Okay, it is a linear factor, I guess. All right, so synthetic division, take the opposite or the 0 of the factor, 3, put it in its own little hut. Okay, notice the coefficients here are all present. All the terms are present, so I'm going to write down the coefficients. 6, 7, -1, and looks like 26. All right, leave a blank row. All right, remember, these are the coefficients of the third degree dividend. So when we get to dividing, these are going to be the coefficients of the quadratic quotient. There we go. Bring down the 6, multiply by 3, add and get 25. Oh, goodness. Times 3 is 75. This doesn't look right. Write down 6, multiply by 3, got 18, added 25, yep, 75. Okay, 74. Okay. 74 times 3. 3 times 4 is 12. 222? What? Add down 248. I'm going to put you on pause. I got to go back and look at this problem. It just seems strange. Well, yeah, it's strange, but it's right. Yeah, it was problem number 25 on page 277. Strange. Okay, so the remainder is not 0. This is our remainder. The remainder is not 0, so we can't say that x minus 3 divides evenly into the third degree equation. All right, so let's look at the setup of what we just found. When I performed the shortcut division, I ended up with, remember, these are the coefficients of the 1 degree down from your given problem, quadratic quotient. So it's going to be 6x squared plus 25x plus 74. Plus any remainder, and we do have a remainder of 248. and we put that over our divisor of x minus 3. Okay, you're probably getting the hang of it, so let's kind of bring in another problem where we have something just slightly different to see how we would handle that situation. Yeah, we're going to do synthetic division. Yeah, we can use the shortcut because this coefficient is 1 and this exponent is 1. It's a linear factor. All right, so the 0 of this factor is -8. Box. We have a coefficient of 1. Notice the x squared and the x, the linear term, is missing. So we're going to put in a 0 for the x squared and a 0 for the x term, and then 512 here. Bring down 1. The product is -8. Collect down is -8. The new product is 64. Bring down 64. The new product is actually -512. So we're back to a remainder of 0. So x plus 8 divides evenly into the third degree. So rewriting this. As a fraction. The quotient, these are the coefficients of the second degree quotient. So that'd just be 1x squared minus 8x plus 64. You could check your work by taking the quotient, multiplying it by the divisor, boxing it, whatever, and seeing if you get there. Okay, you can write this numerator in factored form by just saying it's the numerator equals the denominator times the quotient. I'm just writing it this way because, I don't know, this just shows that this is the quotient by using the shortcut. Okay, and one last one you guys can try on your own. If you want to stop the video, attempt it, and then turn it back on, I think that's a good idea. Okay, so pause it and turn it back on, and when you're done, you can see the answer. Okay, and there it is. Hopefully, if all went well with you guys too, we agree. So I got a remainder of -44, and all the numbers in front of -44 here on this last row indicate these are the coefficients of your quadratic quotient, and so I wrote it this way here. All right, so these 4 examples should help you through at least problem 30. All right, and then go ahead and attempt them, and on Tuesday when we get back from the break, if you have questions, of course, we'll go over them then. All right, and that concludes Wednesday's tutorials.